Hello students. Let us begin this module with a very interesting activity. As you can see, I have a wooden piece and a toy car here. They are both of almost same weight. Now this piece here has a flat bottom, whereas the toy car has these wheels at the bottom. Now let us place both of them along a straight horizontal line. Let me give a flick to the wooden piece. Notice how it went forward when we applied force on it? Now, let us flick the car with the same force and see what happens. Did you notice? The toy car went past the wooden piece and fell off the platform. We applied nearly the same force on both the items, but the toy car covered more distance. Can you think of a reason for it? Very good. The toy car has wheels, and that makes it easier to move the car. Do you know why it is so? Yes, because it is always easier to roll than to slide a body over another. When the movement occurs due to rolling, it is known as rolling motion. Now students, whenever there is motion, there is force acting against it due to the contact of the moving object with the surface on which it is moving. Do you remember what it is? Amazing. It is known as frictional force. Friction is not an active force, as it comes into play only when we try to move one body upon another, or when a body is in motion. Therefore, we can say that a friction is a reaction force. A frictional force is a force that opposes the motion of an object due to the contact of the moving object with other bodies. So students, in this module, we are going to learn about a type of friction, which is rolling friction. Now, in one of our previous modules, we have learned about friction and its types. Let us have a quick recap. Friction is of two types, that is, static friction and kinetic friction. Now, this kinetic friction is further divided into sliding friction and rolling friction. So here, let us talk about rolling friction. I'm sure you remember this toy car that we used earlier. The wheels roll on the surface rather than slipping or sliding, and thus the friction gets reduced to a great extent. And students, do you know what this type of friction is known as? Yes, it is known as rolling friction. This is because the wheels on the toy car rotate on the surface. And students, when one surface rotates as it moves over another surface without sliding or slipping at the point of contact, then the frictional force that acts on it is termed as rolling friction. Now technically, it's not friction, it's rolling resistance, since when a body rolls perfectly upon a surface, there is no sliding friction between the rollers and surface. Therefore, it is easier to push the toy car having wheels. So students, can you tell me which force would be lesser, the rolling frictional force or the sliding frictional force? Well done students. Rolling frictional force is always less than the sliding frictional force. And that is why it is easier to move something that has wheels. Well, to have a better understanding, let us try this small activity. We know that placing wheels at the bottom of any surface makes it easier for the object to move. So, here we have a heavy box, and we have to slide it on the table using a spring scale. So students, now I will pull this box using our spring scale until it just starts to move. Now as it moves, we would note down the reading that we have got on our spring scale. So as you can see, the reading is 72 grams weight. Now let us take these cylindrical shaped pipes and place them parallel to each other on the table, like this. I will place the same box over it. And again, using our spring scale, I will pull the box and note down the reading. So, the reading is 12 grams weight. Now students, what do we observe from this? Yes, we saw the pipes rolling as soon as the box moved. So, you can feel it is easier to move the box this way than to slide it. Do you think that resistance to the motion of the box has been reduced? We noticed that the reading is less than the previous reading.